And now it's a genuine pleasure for me to introduce our Day 2 keynote speaker. Dean Kamen is an innovator, but not just of things. He hopes to revolutionize attitudes, quality of life, and awareness. While still in high school, Kamen developed the first portable infusion device which delivers drug treatments that once required round-the-clock hospitalization. And through DEKA Research and Development, which he founded in 1982, he developed a portable dialysis machine, a vascular stent, and the iBot, a motorized wheelchair that climbs stairs. Kamen is a huge believer in education, and in 1989 established the nonprofit FIRST to inspire teenagers to pursue careers in science and technology. FIRST sponsors lively annual competitions where students from teams form teams to create the best robots. Dean is deservedly one of the most famous inventors of our era. I've invited him to speak here not because he's a specialist in computer vision, but because he's a specialist in pushing frontiers of technology to create practical solutions to real-world problems, and because he sees computer vision as a key enabler for his most important current projects. The way I think about it is this. Throughout his career, Dean has been delivering innovations that are ahead of their time. Most of us here are focused on integrating computer vision into systems. I think we should think of Dean as our customer from the future. There's only one of him today, but I think in a year or two, there'll be hundreds, and in a few more years, there'll be thousands of people trying to do the kinds of things that Dean is doing today and wanting to use computer vision to do them. So I think we'll all benefit from hearing Dean's unique perspective on the things that are becoming possible using computer vision and the challenges that we have left to overcome. Please join me in welcoming Dean Kamen.
Don't try that at home.
Welcome, Dean.
Thank you very much. What Jeff said way more eloquently than I could was essentially why I first declined his invitation to come here. He politely turned it into the positive that I'm not an expert or even a novice at all the systems that need to come together to make embedded vision a useful tool. I said to him, I've got about 500 engineers at my company. We've spent now decades using off-the-shelf technologies. We didn't invent lithium batteries for this new generation. We didn't invent the processors, the solid-state gyros, the other sensors that make this possible. I try to look at what's going to be practical as a new technology that can address an old problem. Wheelchairs are a very inadequate solution for somebody who wouldn't be able to see over this podium to talk to you. So I explained when he asked me to come, why don't you get Takeo Kanade? Yeah, I did. Well, I'm certainly not going to compete with that guy when it comes to what all of you people do. And I walk through the booths and I barely hang on. Well, this thing is 3.5 million deep nodes, neural network. But don't worry, we have a customer. The amount of stuff that has to happen to make embedded vision a simple tool to replace a micro switch, but has lots of advantages, I think is enormously exciting, but I'm going to be, as he said, a customer for it. So if you're expecting me to give you some insights on how to do what you do, you're going to be disappointed. The reason that I actually agreed to come, hey, Jeff, you're going to fill a room with a lot of low-hanging fruit. People that I need for at least 3 very important reasons. I need to take the next generation iBot, the prototype of this one. You'll see a 15-year-old one in a minute in a slide. And I need to put enough sensors on it that we can improve its safety and usability by the disabled community in all the same ways that the whole industry, the largest industry in the world, transportation, is trying to embrace what you're doing for instance, for automobiles. I have some easier tasks, maybe shorter distances, longer time. I have some tougher tasks. I don't have the power budget they have. So I came figuring I'll learn that some of you may be able to help us. The second reason is and I'll talk briefly about it. Sadly, I'm going to have to talk very briefly about each of these things because each one of them I'd love to spend an hour on. But about a year ago, the United States government, the Department of Defense, not the NIH, who would you think would do this, the National Institute of Health, not the National Science Foundation, but the Department of Defense gave us $80 million to stand up a new industry, basically, figure out how to take the miracles in petri dishes and roller bottles in all the medical institutions that are funded by the NIH, the NSF, and bring to scale the ability to manufacture replacement human organs. And anybody here that thinks it's difficult to manufacture chips or cars, think about manufacturing in real time human organs, keeping them sterile, keeping them appropriate, making sure that when you deliver them into the sterile field, there's probably only one of them. It's got the genes of one particular recipient. How are you going to verify, validate, process control, how are you going to do that at scale? And I think the tool that you guys have, if properly, no pun intended, focused, for instance, through real-time microscopy, might help us turn the miracles in these roller bottles, the miracles of science and biology, into an industrial scale solution to a problem that is causing misery, chronic treatment of people, whether it's if your kidneys don't work, you're on dialysis. That's my day job. If your pancreas doesn't work, you're getting insulin or getting it from a pump. Nobody likes to be chronically treated. Everybody would rather be cured. If you get a replacement organ from somebody, you're going to take immunosuppressants for the rest of your life so that you don't reject their organ. It means you also don't reject the next cold. That's also problematic and expensive, and you can wait years before you get that donated organ from an unknown source. There's 400,000 people now waiting for organs. About 25% die every year waiting. If we could custom manufacture an organ, take some iPSCs, induce pluripotent stem cells out of you or the donor, put them into the organ, then they go back into the recipient, which is the same as the donor. It's like my starter motor or my generator in my car didn't work. I took it back to the dealer. They replaced it with a part from the original equipment manufacturer. It works. The rest of the car was fine. Now the replacement part, now you're all fine. In order to bring that to scale, we have to literally invent some processes, some controls, some tools. And I think embedded vision is going to be a piece of many, many aspects of it. In order to get the government to let us take the approach we took, they said, you better match it with another $80 million. And I said, I will, but I won't get it from the med schools and the labs. I'll go to the industry that knows manufacturing. For instance, I don't know if they're represented here, but I went to the Rockwell Automation, one of the biggest automation companies in the world. I said, hey, you've automated all sorts of other industries. The basic understanding and processes that you do, we need to apply them to create a whole new industry. The same way Silicon Valley put an infrastructure and an ecosystem together to make all things semiconductors real, reliable, and cost-effective. We got to do that. They not only agreed to support it, he joined my board, their chairman. We didn't get $80 million of matching funds. We got well over $215 million. We have about $300 million now dedicated to creating the tool sets to build human organs. And I've told the DoD we're going to have some of them coming through the FDA within 5 years. That's a very aggressive goal. The third thing I need from all of you, since probably every one of you knows this is such an exciting field, one of the things you all feel the pain is, I can't find young people to come in and meet the needs inside my company. And the people I want to work with as customers, suppliers, vendors don't have people. You can each fight over the few that are coming through our universities now, and that's a zero-sum game. Or you can help create and fill the pipeline for future talent in a world that is in desperate need of more and better and more passionate engineering folks. And I started first for inspiration and recognition of science and technology nearly 30 years ago to help fill that pipeline, particularly to attract women and minorities in this country, and now, as you'll see, around the world, to start thinking about the world of engineering as every bit as much fun, rewarding, as accessible as bouncing a ball or sports. But they're hammered every day in all media with role models and superheroes from the NFL, the NBA. They all know about Hollywood and the Grammy Awards, the Academy Awards, and all the exciting stuff that's going on here, all the stuff that can transform the world as they will inherit it, is being done by a small group of people they've never heard of. The incredible, fun stuff, amazing stuff you do, they're unaware of. And in a free culture where you get what you celebrate, it's not a surprise that we have so many kids that are chasing the great lie that their life is going to be meaningful because they're going to play sports or be entertainers. Recognizing that they're driven, it's not a supply problem. As many people think, it's not an education problem. In a free culture, you get the best of what you celebrate. And so nearly 30 years ago, I said, hey, we know what works. We know what gets kids passionate, sports and entertainment. Let's make science and technology an entertaining sport, particularly for girls and minorities that have virtually no role models that aren't from the world of entertainment or sport. And maybe we'll change our culture back to one which will help lead the world by having the world class and sufficient capacity to drive innovation in the future, as we did for the first couple of 100 years. So I'm hoping, whether you're an individual and you want to be a mentor, or whether you're a company that can be somebody that supplies support to a local school where you are, we need to make FIRST available all over the country. And as you'll see now, we have a program to make it available all over the world. Trying to discuss my needs to sensorize this, to create a whole new industry, to get FIRST going. And by the way, I've got a few empty seats in my plane. I'm also looking to fill about 100 new spots at DEKA to do this project, and my regenerative manufacturing is going to be really hard in what must be, there's supposed to be a clock in the 36 minutes that's left. So I'm going to quickly give you an overview of the life before embedded sensors as I saw it, and then life with embedded sensors as I see it now, and hopefully with life in embedded vision in the near future. And then we're going to go on to FIRST. As you heard, I was making these things in my parents' basement for my older brother when he was still in med school and I was in high school. It was a pretty simple thing. It pushed a syringe. But you had to do it with precision. Well, the most precision I could get, you put a micro switch on a lead screw and you count revolutions. In the advanced ones, I used Hall effects and they had multiple poles. I got more resolution. I never would have thought, why don't I just put a vision system and actually look at the position of that syringe? And maybe I can even see if it's got air bubbles in it. And maybe I can make sure that I can deal with issues like hysteresis and backlash and stress and strain that you can't with a simple switch. But when I was in the early part of my career, pretty much every closed loop system, and you don't do engineering without closed loop, we all know that, but it was given that you use switches, whether it was resolvers at the end of a stroke, because vision, even maybe a beam breaker, was sort of on the edge of being right, but not that good. But as I said to Jeff, I believe we're coming to a point, and you walk through this place, I think it's undeniable, that we're soon going to be in a place that, in the same way, if I ask a young engineer in my place to make a light turn on and off once a second, I would have done it with a gate, flip-flop. They'll use a microprocessor. It's cheaper. It's one part. It's easily codable. You know, Arduinos to them are like resistors, or transistors were to us. In the same way, your integrated packages are getting so much better that the next versions of these do have cameras and vision systems that give us way more feedback and information, as you'll see. This is the first home dialysis machine we made. You open that door, and a cartridge goes in, but we have all sorts of sensors, mechanical ones, switches, to make sure things are going right. And you still had to aseptically cleanly connect the bags of solution that sit all over this thing to make it work. I'm going to show you something we did that had nothing to do, and as of today still will have nothing to do, particularly with embedded vision. But I use this and the following slide for a very important reason, even when I talk to my own group and when I talk to other engineering companies. I think most innovation in any one industry happens when people in that industry randomly or intelligently or go into some other industry that might have faced a similar problem much earlier in time and solved it. I was asked by the folks at Johnson & Johnson to help fix this. I wish I could say I invented the stent. I did not. That was Pamaz and Schatz. But after 15 years of development, their patents were almost gone. They had made this great stent. It was 316 stainless steel. J&J had the rights to put it out and said to me, Dean, we know that soon competitors will make better ones that are more flexible, more this, more that, more that. Help us make this one better. We need the next generation fast. I said, I don't have a lot of people that do stress, strain, elastic deformation of 316 stainless steel to within 5% of yield, which is 75,000 PSI on the little things. And I suddenly said to myself, actually, I do have guys that do that, but they're not at DEKA in my place in New Hampshire. I happen to have the advantage of, I own a helicopter company. I built about 1,000 of these. That's me flying. And I realized that the aerospace industry has been worried about elastic deformation, stress, strain, and fatigue life for 50 years. We call a little nut up here the Jesus nut. Something goes wrong up there, it could ruin your whole day. So I called a bunch of those guys and said, do we have any really good, and this is 25 years ago, do we have any good models that'll even do nonlinear, I want to expand a piece of stainless. Sure. In 6 weeks, they designed a solution. We implemented it. It worked exactly like the model. Everybody was very happy. My point is, we went to the FDA with a device designed by a bunch of motorheads at an engineering company, basically an aerospace company in Michigan, because we just went outside the realm of the medical companies to find a better solution. I think you walk around this place and you'll see that there's a lot of really neat ideas that have been well developed for other purposes in other industries that are now desperately waiting to have embedded vision be a way to simplify, improve quality, improve reliability, and make their systems better. Again, about 30 years ago or more, a friend of mine came to me with what was then the earliest version of machine vision. Again, I didn't invent, I was not the founder of SciTech, but at the time he could show me in my office that he could put a slide under a microscope, and as long as there was a monolayer of cells on it, he could teach. And this is when it took big mainframe boards to do this back then. It's almost the days of mini computers. And he could relatively quickly teach this thing to show a bad cell, a cancer cell, or a precancer cell from a good cell, which would be a huge win because about 80 million pap smears get read every year. His problem was, and you guys can now appreciate this, a human is so naturally good at changing the focus, seeing that things are clumped up, not being tricked by the fact that it looks dark because it's a big lump as opposed to a bad cell. He said, my system works great, Dean. He was expert back then at computer vision, at machine vision. But he said, I need good slides, and they weren't easily made. Well, I make a lot of stuff that moves and measures fluid, like dialysis and insulin pumps. I made a device that would absolutely perfectly lay it down a monolayer of cells on a slide. I wish I could tell you it's really neat. It's this machine. There's no vision system in there. He took it to the FDA, and instead of giving the approval, what they said to him was, we can't approve your machine. The reason you're getting such good results is because you have such great slides. And we're not yet even prepared to understand how to compare a human reading of a slide with your machine. They rejected his. It's a long story. But he came back and said, Dean, I'm just going to make you a machine and start selling machines that create slides for the world. It became $1 billion business. It took almost 15 years before they finally added onto it the ability to read those slides other than manually. It's now done that way, but it was 15 years ahead of its time. This is a version of this machine in 2000. I only put it here to say, by the way, it had no vision systems. 15 years later, it weighs 50% less than the original. The batteries went from nickel cadmium to lithium. The processors went from big, massive boards that took lots of power to one single board. The multi-$1,000 IMUs with incredibly delicate solid-state gyros are now a postage stamp and a couple of bucks. But I still need the sensors. We have 10 million hours of operation on these things. Not a single machine ever went down because of a system failure. We had all of our triple redundancy worked. But we have loads and loads of disabled people that went down because just like you and I, they weren't paying attention, they slipped, they tripped, they didn't see that curve. I need to solve their problem the same way you need to solve the problem for the big auto guys. I'd argue they need it even more. They have more of a need. From that came this. I throw that in there because even though it came from one of my medical products, I'm forever known as the Segway guy. I just realized with time running out, I'm not going to spend a lot of time, but this thing is a way to make electricity from any source of fuel. We electrified 2 villages in Bangladesh from the methane coming off a pit full of cow dung in each village. That runs this Stirling cycle generator that makes a few kilowatts. Some of its power would run this vapor compression distiller that would make 1,000 liters of pure water a day. I did that. I needed to get them out there. My medical partners aren't the ones to do it. There's only one company I knew of at the time that does business in every country, in every little village in the world. That's Coca-Cola. I went to see the chairman of Coke and said, will you help me put these in schools, in clinics around the developing world? Bad water is 50% of all the hospital beds in the world. It's the #1 killer of kids. He said, I got a problem of my own. I want to make better, essentially make my beverages not with a little thumb on a, basically, he said, my bottles and cans are now up to 100 different SKUs. I want to be able to make those kinds of beverages in real time from a vending machine. You do all sorts of fluid control. Can you help me? Can I help you? I suppose so. I never got up in the morning all excited to build a commercial vending machine, but how about if I build something that you really like, on a handshake, you'll help me put these machines out, at least in a trial, through your 125-year-old network around the globe. He agreed. R&D to them. He said, Dean, you know that black machine? Can you make it red? I did. This is the machine. You've probably used these by now. It's full of basically the technology we use in the medical industry to precisely control delivery of fluids. The Freestyle makes this. We've built tens of thousands of them for you guys that do embedded vision. Wouldn't it be nice to walk up to this machine? It knows who you are. It knows which stuff you like, and it can make it for you. Yes. Are they interested in that? Of course. We can talk later. Here's the machine. It's red. It's at the Olympics with the chairman of Coca-Cola. I wish I could spend more time on this. We were asked by the Department of Defense about 10 years ago to build the next generation of prosthetic device. We've been giving the same garbage to people that have literally given their arms for this country since the Civil War. A 2-pound hook on the end of a wooden stick is what they got at the end of the Civil War in 1865. Today they get a 2-pound metal hook on the end of a plastic stick. They asked us to make a fully integrated 13-degree of freedom arm. You'll see where vision comes in later. We did. Here's a guy who's bilateral. He is punching one of our controls guys who's sitting right here somewhere. And conveniently, this guy is another one of our engineers who also happens to be a Harvard Med School trained surgeon. These two guys are demonstrating the fine motor control. And in a minute, from this home video that we did of these two guys, I got what I think was the most compelling feedback I've ever gotten on anything we've done. This guy picks up a spoon, holds it level, and starts eating cereal with milk on it and doesn't even drop any. Here he goes. I can't do that. His wife is standing behind me, and since he's bilateral, she says, Dean, Chuck hasn't fed himself in 18 years, so you got a choice. We keep that arm or you keep Chuck. He now does what we were asked to do using haptic, efferent signals and sensors we put in there. He's eating a grape. You don't do that with a 2-pound hook. That was Gen 1. This is Gen 2. We've now got a bunch of these out on people, including we have one person now that's wearing a pair of them, bilateral. Again, I'd love to talk to you about how vision systems tied into this thing can give it some capabilities that you'd wish you have. Everybody I know, if you ask them, if you could have a third eye, where would you want it? They say here, and then the smart people say, that's stupid, it's redundant. I put it back here so I can see everything. Yeah, that's not that clever. I put it at the end of my finger. Just imagine what you could do with that. Anyway, we have some very neat ideas we'd love to talk to you about, but I don't have time for that either. It was cleared and it's out there. This is a new version of that first machine I showed you for dialysis. We've shipped more than 600 million therapy cassettes for that. It's become the world standard for home dialysis, but you still have to manually connect all those tubes, and if you get them contaminated and end up with peritonitis, you're in trouble. Again, I don't have time for it now, but it's been almost 20 years from the first one to the second one, even though this one's much smaller and it has this beautiful, nice display. When you open the door in this one and put your cassette in, you just lay in, still in their sealed package, all the lines that go to the bags of fluid. Inside that door are some cameras and some systems that strip the wrapping off, aseptically make the connections, visually inspect them for air, for leaks, and then the therapy goes. That's a huge improvement, and it's the first example of something in which we actually have embedded vision systems to make it better. In the old days, they would have a beam that would be broken by a drop. Everybody here has seen a hospital. That's not a very good way to control because the flow is continuous out of the bottom, but the drops form and then once in a while drop off or shake off. If you try to do closed loop around that, you're chasing your tail. We actually took cameras, a little bit of simple software. As Jeff pointed out, these days we sort of get it almost off the shelf from you guys. And this video is showing us looking at that drop being formed. That's measuring flow. And the last time I checked, every drop that comes off of something is spherical. I've never seen one that looks like an octagon, and they're all pretty much round. And their volume is 4/3 pi r cubed. Geometry is as old as Takeo pointed out. 300 years ago, Taylor knew how to do a series. 3,000 years ago, people knew how to figure out the volume of a sphere. So we have very precise ways to do control. And believe it or not, a camera and the software to do that right now takes less power and is smaller than the beam breakers were in the 1970s. This is the new version of this thing I'm sitting on. We just got it cleared by the FDA. We're very excited by it, but it's still missing. This is now a modern car that doesn't have any of the stuff that people want to put on cars. This is what our lab looks like, and we'd love to have some of you guys or women come back with us and help. This is really exciting, by the way, not only because this is the only mobility device that'll climb stairs. This is a really exciting set of pictures because it's probably the only one in which you'll see women writing code and being real engineers. It's a rare commodity, but I think Emily is here, one of my engineers. I don't know where she is. I'd love to populate DEKA with about 100 more. My guess is there's at least 1,000 openings from companies in that room, and we're going to move to first in a minute to figure out what to do. But using the technology that is represented in that room, we look at these curbs, we figure out if it's red, don't try to go there, Grandma. The joystick won't let you. We map a parking lot outside my office. These are the cars. If it looks like this pattern, you can drive there. If it doesn't, you can't. We've got to be able to make these things simple, safe, and reliable. That's one of the reasons I'm here. As I told you, we started a new not-for-profit, Army. Whenever you say the word regenerative, people think it's going to finish with medicine, regenerative medicine. It's all out there, people. For 20 years, some of these miracles have existed. They're just not available clinically. So we formed an organization. Since I got all the money from the DOD, we called it ARMY, but it's Advanced Regenerative Manufacturing. Institute. And this M is where you people come in. As you can see, our mission statement is to bring these things to scale. We are not doing basic research. We are not doing proteomics, genomics. We're not doing all the stuff that happens in the med schools. They're doing a good job. The proof of that, most of you might, if you're old enough, remember, this is a pretty exciting picture. They know enough now that they can take a human genome, a rat genome, modify things, and you can grow a human ear on the back of a rodent. This is pretty astounding. Just think about that. But here's the sad thing. That was the cover of that magazine 21 years ago. If you ask what's happened since then, this is what the laboratory still looks like. Manual labor, beakers, pipettes, petri dishes, slave labor like grad students every 2 hours come, inspect it, using judgment, move the bad stuff, move the good stuff, sort it out, try to keep it sterile. It's never going to get to scale. They have the miracles. It needs to change. This is a slide we used to create this thing. We pointed out that the government through NIH, and they've done a great job. We pointed out that industry, big pharma, they're there. This big gap where most people think it's still impossible, it's still too risky, it's still a dream, it's still undefined, that's where we are. You saw slides from Jeff. These are the companies that have already signed up to help us do this. Some of them may be here. Some of them that are here should be on this list. These are the med schools that we're working with, the ones that are delivering their miracles in their roller bottles, in their petri dishes that we need to bring to industrial scale. Where are we going to do it and how are we going to do it? This is a picture of Manchester as it looked in the 1860s when it was the largest single operating industrial complex in the United States. It was on the cutting edge of automated textile manufacturing, 22,000 looms and knitting machines. This is what it looked like during the Great Depression when they closed. This building right here is now my headquarters. Last year, Politico described this milliard in this city as a marvel. I moved in the 80s out of New York into the first building. Then as I said, I filled about 4 of these buildings with 500 DEKA people. Now we have first filling 150,000 feet across the way. Magnificent old 160-year-old buildings. Autodesk, Texas Instruments, the only company that's now making organs. We now moved the whole University of New Hampshire's new campus to help us do this, and DEKA is now taking over to make Mobius, the arms, and now this entire building, plus another 250,000 square feet down here, will be fully occupied by people to help create this new industry. Among simple things we need from you, real-time vision that can look in and through media to watch cells develop, help us document it, verify it, validate it, do process control, help run the robots that can sort these things out at a cellular scale. If we can do that, I couldn't resist this. We're here in Silicon Valley. I think this milliard, and if you think the semiconductor industry is big and these markets are big, healthcare right now is already over $1 trillion market, and it's by far the fastest growing cost to the government of the United States and most advanced countries in the world. We've got to find a better way to cure problems. We will bankrupt each other, making ourselves miserable trying to treat these problems. But this milliard, with all the different technologies we have in it and intend to bring to it, I'd like to think can become the Silicon Valley of regenerative medicine. To do it, we're going to need a lot of smart people. We're really running out of time. That clock is very intimidating. So I'm going to start with a 1-minute video narrated by the voice of God, Morgan Freeman, who will give you a very quick overview of what FIRST is with some visuals in the back so you'll know I'm not kidding. It's not a science fair masquerading as sports or entertainment. It's every bit as exciting as any other sport. The same trappings, cheerleaders and school bands and mascots and instant winners and losers and no midterm exams, just trophy. It's a sport. It's no better. It's a sport like every other sport. What makes it different is it's the only sport that every kid can turn pro. So here he is.
This is the Super Bowl. The Super Bowl of smarts, that is. It's a life-changing competition. It's kids having fun, competing, working together to dream up, design, and build robots.
It's just an exhilarating feeling. It's like I'm using power tools.
They're having the hardest fun they'll ever have. And they're becoming our next generation of engineers and innovators. First, come out! For inspiration and recognition of science and technology. My teachers were some of the greatest influences on my life by challenging and trusting me. These mentors got me to understand that I could do anything I put my mind to.
I feel like I can go and do anything I want to do because of this program.
Someone took the time to guide and inspire me. It changed my life. Take some time. Go to usfirst.org.
So I hope every one of you that is strongly embedded in the U.S. will go to usfirst.org and help us get more teams around this country. To give you the really quick overview, I won't spend a lot of time on each one, but at least you think I'm kidding when I say it started with 23 companies that adopted 23 high schools in 1990, and it's had 55% compound annual growth for 27 years. This year, we ended the season with slightly over 61,000 schools, 160 events throughout March Madness, regional events in 160 cities around the country and around the world, 3,700 corporate sponsors, 200 universities scouting for these kids at these events, handed out at the championship, which we did in the Houston Astrodome a couple of weeks ago. We handed out $80 million in scholarships from every major tech school in the country. But to show you the growth, some really quick pictures. That's the foyer of my old mill in Manchester when I told the then President of the United States, look, I don't need the President to get involved. You'll turn this thing into a science fair. It'll turn into curriculum. It'll be as boring as everything else. What I want the President of the United States to do is bring the winners to the White House, the same way you bring the winners of the Super Bowl, the World Series, Academy Awards, and put a spotlight on them and show the public that kids that are going to create the future also ought to be recognized in the same way. There's been 5 presidents each year since we started this. We've had the White House visit. This is everybody in the world that knows what FIRST is in that first year in a high school gym in Manchester, New Hampshire. By the next year, a different president's got the kids in the White House. We have to move out of New Hampshire because there's no venue big enough to hold the championship by '95. By 2002, we have to move out of Disney and move into the Houston Astrodome for the first time. We moved back there again after 20 years this year. Then we moved to the home of the 1996 Olympics. Then the third president is bringing kids to the White House, not known for his love for science and technology. Yeah, you can chase the President of the United States around the White House with a 120-pound robot. And no, the Secret Service has absolutely no sense of humor. So this is where we were for the last 5 years. This president certainly embraces FIRST and tech. He has data on where we are as of this year. At least you think I drink my own Kool-Aid. An independent group, Brandeis University, was paid by the Ford Foundation to do longitudinal studies of the impact of FIRST on the schools they're in. This is their numbers. In the world of education, you write a paper if you had a 4% change in something. This is a 400%. This is a 4 times change. We double the number of, for instance, women. It transforms the school that it's in. These are the schools, or some subset of the schools that this year gave out the scholarships. These are among the 3,700 companies that have figured out they better start investing in these kids when they're young, because these companies are in desperate need of the next generation of these kids. For those of you that say, well, I only do, so I don't build robots. We are getting so heavily entrenched in giving them relevant new tools, development tools, programmable logic controllers, vision systems. I'm going to show you a quick video we put together. These are middle school and high school kids over the last couple of years in the competitions. We're in the kids. They had a total of 6 weeks to build. This is what these kids are able to do. The music in the background is Will I Am. And he changed the words a little bit and re-recorded it if you listen. But he did a halftime show for us right after he did the halftime show for the Super Bowl. And he got so taken by it, he's now going to do one for us, which I'll tell you about in a minute. Listen.
You could be the best. You could be an engineer and a scientist. You can help the world. You can find a cure. You could be first. You could be the leader.
You can throw your hands up, you can beat the clock. You can move a mountain, you can break rocks.
You can be a master, don't wait for luck. Dedicate yourself and you can find yourself.
This, Standing in the Hall of Fame, is the name of that song. He won a Grammy for it. You saw robots following each other. They're doing that with vision systems. They're doing this with vision systems. They identify that cart, that can, that's a scoring device. These are kids. And we need mentors for these kids. And by the way, if you make some of this stuff, we need it to throw into the kids to keep the kids exciting. Slight change and improvement. It turns out that even the little country of Israel a few years ago was up to 1,200 first teams. Before he passed away, Shimon Peres said to me, Dean, you've got to make FIRST truly global. It's not good enough that it's going to fix America. The world needs it. The next generation of kids around the world need to know how to communicate and cooperate with each other. And the universal language of science, of engineering, is the best way to get them there. If we continue to let generation after generation around the world each teach their kids and their grandkids their own truths and their own customs and their own religion, they'll continue to repeat the same meaningless, self-inflicted wounds that he said in the Middle East they've been doing for 2,000 years. He said, let's give all kids FIRST global. Let them learn how to cooperate, communicate, build a world together. So I formed a second organization. This was after I got a letter from him saying we need to do this. And in the second organization, this is where we were, by the way. This is where I had teams anyway from FIRST, because all you multinational companies had teams, but they all come to the US. We said, no, we're going to do what the Olympic Committee did for NBA basketball by making it truly global. We formed another organization that's not FIRST Inspires. It's called FIRST Global. And it's going to allow one team from every country in the world to compete once a year in this celebration of tech to help get that country to start putting FIRST teams all over its population. To explain that, I went back to the same guy that did some of our other videos, said, hey, John, I need a really passionate video, but this one's much harder than Morgan Freeman. He just had to say what it is. I need a clear statement to the world that FIRST was never about robots. You know, we're not using kids to build robots. We're using robots to build kids. I said, John, I need a way to show that it's about self-respect, communication. I need a way for these kids to see that it's the way out of poverty. He puts down his pen and he says to me, Dean, you asked me for a 2-minute video that's going to explain why there's FIRST. The only thing you've said for an hour and a half is it's not about robots, but I go to all your events. It's all about robots. I thought he was going to say no. And I said, John, I'll bring you back Morgan Freeman. Nobody can afford him. I get him for free. You know he loves us. His pen's down. He says, Dean, if you really want the world to understand the impact that FIRST can have, I don't need the voice of God. I need a 7-year-old girl. And this is what he gave me. I sent it around the world, and I didn't get 30 companies to send teams.
This isn't a robot. It very well may have hydraulic arms, a drivetrain, and a circuit board, but this isn't a robot. This is a lesson in humility, hard work, and collaboration. This is a CrossFit workout for the muscle upstairs. This is an apple for the next generation of Newtons. It's a lot of things, but this isn't a robot. This is a roadmap that leads straight to engineering. This is a rock to shatter 1,000 glass ceilings, a rope to pull a generation up and out of poverty, a sledgehammer to break down cultural barriers, and a universal language spoken in every nation on earth. And because of that, this is a compass that can help point the way to peace. But please, don't think this is just a robot. This is Glastonbury for technology. This is mission control for the next moonshot. This is the Rosetta Stone to help translate the future. This is the sport that will help us win tomorrow. This is the software to program ourselves to cure cancer, build a clean engine, or step foot on Mars. But this isn't a robot. It's a machine to build the people who will change the world.
So I sent that around the world to people I knew a year and a half ago, hoping that at that one joint meeting that the National Academy of Engineers of the United States was hosting for the Chinese Academy and the Royal Society, all in Washington, D.C., I would have 30 or 40 countries take our new kit and have kids from around the world come in with their flags from their countries, just like they do in the Olympics, being proud of what they did, to demonstrate to these organizations that it's time for them to start helping. They're very good, these big organizations. I'm a member of the National Academy of White Papers to the White House. But we as organizations don't look down to fans the way the NBA, the NFL. Well, it's our fault that there's such a shortage. I thought I'd get 30 or 40. I had 157 countries. From Afghanistan to Zimbabwe, 157 countries. I scrambled. I rented Constitution Hall in Washington. We put the event in there for 3 days during the meetings of the Academy. It was astounding. As a result of it, we said we got to do it again next year outside the US, just like the Olympics. We're taking over. You're all invited. August 15th to the 18th, the largest enclosed arena in Mexico, Mexico City, on the 50th anniversary of the Athletic Olympics, the 68 Olympics in Mexico City. I'll have well over 160 countries represented. The theme of the game this year is energy. The theme last year was water. I'm happy to tell you, by the way, that a couple of weeks ago, I was lucky enough to be sitting with Brian Krasanich, the chairman of Intel. I know they're big here. I said, Brian, the proof that we are the future, engineering and technology is more relevant to kids than a 2,000-year-old sport like synchronized swimming or shot putting or javelin throwing, is they just closed the South Korea Olympics with the biggest drone show the world's ever seen, synchronized, that you made. I need that show done for people that appreciate science and technology. And let's do it in that arena in Mexico City. He agreed on the spot, so it's going to happen. We're going to have a spectacular 3-day event down there. And by the way, this is what we looked like last July 17th. This slide I love because we did an analysis of the 157 countries. 60% of the teams, and we're talking about Rwanda, and Uganda, and Mali, and Somalia, 60% of the teams were started by women. This is what it looked like inside Constitution Hall. It was an astounding celebration of tech. The tech community has better get a louder voice quickly in this country. You better get a louder voice. If you think the world of politicians or the NBA or the NFL are going to make this world safer, they're going to make healthcare problems go away, they're going to make water available, they're going to solve cybersecurity. I mean, you can think that while you're busy doing your thing. We all get an A+ because technology has been driving the quality of life since we climbed out of the primordial ooze. You get an A+ for your day job. Unfortunately, because we're all busy on our day job, we leave society and its mission and its role models to the loud voice of a lot of people that don't add value. And then we wonder why the world does such crazy things. I think we as a technology community get a C for having a voice. And there's never been a time where we could add more value. There's never been a time when the world needs to hear the voice of a reason, a positive voice of solving real problems than now. By joining FIRST and now FIRST Global, we could create a global network of people that will actually fix the world. I think you'll get more out of it than you put into it. Immediately, you'll get out of it your future generation of employees, customers, partners. you'll get out of it the excitement of seeing people recognize how much fun technology really can be, how powerful it is. But I now see that it went to zero and it started to, I guess this is question and answer. So this is what we look like. Here's the this is the 30,000 seat arena we'll be in August. The dates are the 15th to the 18th. This should be a celebration that overtakes the other kind of Olympics by the time we get to 2020, where I intend to be in Tokyo. We intend to be in Montreal next year. It's the other country where they've hosted an Olympics. They've already got 1,000 teams up there. They're already working on helping us create the 2019 event. I have to shut up now. I apologize, but I hope you all can see that in our enlightened self-interest, we, the technology community of the world, ought to start taking over and making sure the right things get done by the right people for the right reasons. Thank you.
Thank you so much, Dean. I think I speak for everyone here when I say that you are an inspiration, and that was a fantastic presentation. We'll have time for questions. If you have questions for Dean, please line up behind one of the microphones in these two aisles. In the meantime, it seems trivial to get down to technical things again, but I want to start with a question or two of my own, if you don't mind, Dean. About this wheelchair fascinates me. And when you look at it, it's basically batteries. It's rolling batteries. And yet you're obsessed with the power consumption of the electronics when we've talked about, I want to add vision, but no, you can't have 10 watts. It's got to be milliwatts. So just help me understand, like you're sitting on a big box of batteries.
Let's do the math. When I'm exactly in the inverted pendulum situation, theoretically, other than a little dither, it takes zero power. If my gravity vector is right through this, zero power. If I lean forward or back, a little bit of power. It's only two wheels on the ground, rolling resistance, only two wheels, no scuffing. Right now, all the electronics, the multiple processors, those beautiful little gyros, 10, 20 watts of power, right? If I'm moving along cruising, 30, 40 watts on a hard surface. Yeah, when I climb stairs, peak power, it might be a couple 100 watts. I got 6 batteries in there. Each one's about 100 watt hours. Let's say you told me, Dean, it'll only take 20 watts to run my whole system, unlike when I'm sitting and not moving where it's zero. If it's 20 watts to add your sensors, let's say the average person's up for 18 hours a day. Remember, this isn't a fun toy. This is their legs. If they're not in bed, they're in this. If for 18 hours, I'm better at multiplying by 20 than by 18. Let's say 20 hours, 20 watts, that's 400 watt hours. That's most of the energy I'm carrying. It's off the table. I need about 1 watt. If you give me really, really good stuff, might let you have 2. But I'd love to sensorize this thing so that if grandma's not paying attention and that curb sneaks up on her, or you don't want to back over the baby, as you can imagine, I need to do a relatively simple, limited set of situational awareness things compared to a car that's worried about it. 60 miles an hour, I got to look 500 right in terrible rain. I need a cone around me that protects me and the people that I might interact with, that I might bump into. I'm greedy. Grandma's gone out, maybe besides having a physical problem, a cognitive problem, or a vision problem, and it's getting dark, and she's in the park, and she needs to get home. Or maybe you want to call and get her home. Or maybe it's a 7-year-old girl with spina bifida. We want to be able to do mission planning. We want to be able to keep track of where they are. We want to make sure it knows what's going on. It knows how to be safe. And I think the technology that's out there, properly integrated, could be small, lightweight, and reliable, and can be added to this thing in the same way that they're going to try to upgrade cars for the very same reason.
Yeah, well, I think your timing is excellent. I wouldn't say, to use Takeo's phrase yesterday, it's a trivial problem, but I think we're at the time now where getting that kind of capability within that kind of power envelope is, if not feasible today, we're very close. So I think your timing is excellent. And on that point, something I've been curious about, you've created all of these amazing innovations that I think most people would have considered, if they'd been proposed to most engineers, they would have said, oh, that's a science fiction. That's not in our generation. What guides you in deciding, in the judgment of the timing of these things? It's very easy to be too early, right? How do you avoid being too early?
So, first of all, I wish I could say I do avoid being too early. I mean, everybody knows the early bird gets the worm. They never tell you till you burn yourself a few times. Yeah, the early bird gets the worm. The early worm gets eaten. I've been the worm many times. When we made the first Segways, they cost us $10,000 to build because the batteries were on the cutting edge of technology. The solid-state gyros were $1,000. It was a good idea. It was too expensive in the early days. The same thing with these things. You asked about science and science fiction and what we choose to do. I tell all the kids in first that all say, oh, I hate science. I say, really? You didn't like Star Wars? You don't like... Kids love science fiction. They don't like science fiction. I say to these kids, and I'll say it to you, the only difference between science and science fiction is timing. In every generation, there's science fiction. People want to do something. The next generation does it. To Jules Verne and H.G. Wells, science fiction was a device that could go under the ocean, 20,000. We call those submarines. A device that could go into space. We call that this. When I was a kid, we were going to, and to the kids of, let's say, the last 10 years, Terminator. Well, now we clone animals. Every generation turns the fascination with science that was fiction into real science. To answer your question, what we work on, there are certain things I think we won't get past. I look at a project, and if in order to succeed at that, we have to get around, let's violate the second law of thermodynamics. Yeah, not so much. I believe there's certain things we're not going to get around. If it's the laws of man, they're pretty ethereal. If it's the rules of engineering, they're changing at an ever-changing. If the basic science, if the inverted pendulum as solved 100 years ago, if you could make a gyro as good as your inner ear, if you could make a actuator as strong as your legs, if you could process that data as fast as your reflexes, hey, why can't I do this? I'm standing like you're standing. I look at what's out there and say, if the technology matures enough to make that practical, safe, reliable, and affordable, and it could solve an old problem that's not being dealt with very well in a better way, get patients home on that, let them wear a device to be an artificial pancreas, let's go build replacement organs. I want to put myself out of the insulin pump business. I want to put myself out of the dialysis business. I'd rather be on that bus than under that bus as technology changes the world of business, of careers. And I believe, maybe a long answer to your question, if there's a really big need and there's on the horizon technologies that if properly developed can meet that need, we'll work on it, hoping that as we architect and systems integrate the solution, the ability to bring it to scale will coincide with our goal. If it's something that's going to violate a fundamental law of physics, I don't touch it.
So that's really interesting. And when you told me about the Army program, ARMI, I thought those words coming out of almost anyone else's mouth, I would have been like, yeah, sure, manufacturing human organs at scale, whatever, next topic. Coming from your mouth, I have to take it seriously. But I'm really interested in hearing, you said in 5 years, you're telling the FDA we're going to be ready to ship organs in volume in 5 years. That seems to me just astounding. What gives you...
For clarity, we will have organs that are appropriate and capable of being shipped in 5 years. In fact, I was so concerned that technology is now moving so fast, and government agencies, and I'm not here to roll them under the bus, but they don't have the tools to deal with this very well. When we were given that award, in the last days of the last administration, they had a press conference in the White House. They asked me to come, they put me on stage, and I said, I'll be happy to speak, but as you know, I just tell people what I'm thinking, and I'm going to tell the people here the same thing I told all of you. I don't know anything about regenerative medicine. That's not what my engineers do. So I got to the podium. I said, hi, everybody. I'm really excited that the government, the Department of Defense, had enough confidence in us to give us this huge award over and above all these major institutions. You ought to know, I know nothing about regenerative medicine. There's a little nervous. However, I'm not sure that's what's needed here. We need to bring the disciplines of engineering, particularly high volume manufacturing engineering, high quality verification, validation, process control, to a system that doesn't exist in these laboratories. And I said, and I was asked by the DOD to give them a timeline, and I told I'm at the White House. I told them then, I think within 5 years, we ought to credibly be able to make simple. We're not going to make livers, kidneys, and lungs by then, but a cornea, or tissue, scaffolds that have bone, cartilage. Standing at the microphone, I said, we need a system that will allow, and I wasn't beating, allow the FDA to deal with this new set of opportunities with a new set of tools, because if they don't have those new tools, they're there to make sure you can make 12 billion of the identical pill the same way after a 10-year. Well, that's not going to work. We're going to make one of these customized organs made with your cells to get put. How are we going to do that? It's going to be a problem unless we change the way industry, this new industry works with the government. I think the FDA should be on our side of the table working with us, the way the building department works with you to get a building permit, not the way the other government agencies, like you're there for your parole hearing, you're either in or you're out. We can't finish it, throw it over the fence. At the end of that little event, a guy walks up to me, hands me a card, and I know the card. I've spent 40 years working with them, and it was FDA in the corner. I said, of course, I'm in the White House. And I figured, here it comes. You guys are always rolling us under the bus for all the delays of approving products. The guy looks at me and said, Dean, I'm an MD, I'm a PhD, and after doing a lot of research, I left. I joined the FDA, and after 17 years here at the FDA, I'm the senior policy guy on biologics. I think everything you said is exactly right. I think you need senior people now on your side of the table, and essentially over the next few weeks, I convinced him to pack up his desk, resign from the FDA, move to New Hampshire, and he is now up there helping us build an organization that is starting to prepare the documentation and working with NIST so that within 5 years, we are going to have credible systems that we can show the appropriate agencies in Washington that if we can build high quality substitute tissue and systems and organs, we're going to be ready to do clinical work with them. And I will be very disappointed if we don't meet that schedule.
So it sounds like a close analogy to what you're trying to do with Army is what the semiconductor industry has done over the last 50 years, going from a hand-fabricated transistor to a billion transistors, and we crank them out.
I am so glad you said that, because I was grasping for analogies when we sent in our proposal, and some of the reviewers said, Dean, we believe you when you said you know nothing about regenerative medicine. And I said, and I was not being falsely modest. And I said, look, guys, when guys at Bell Labs, finally after years, came up with the basic understanding material science and physics that, yep, glass doesn't conduct. Put a voltage across it, you don't get ions. Yep, copper, yeah, it conducts. What if I could make a material that by changing it, what if I could literally make semiconductors, first a diode and then control the gain transistor? They did it, and they handed the world an incredible piece of knowledge and understanding. But it was not Bell Labs that became Silicon Valley. They delivered beautiful science. Then the engineering community took over, and then they started making transistors. Then they started making integrated circuits. And then companies like Applied Materials came along. And when I started this Army, I called Applied Materials. Mm-hmm. I said, look, guys, you don't make the products that people buy, whether it's a memory cell or a processor or an analog or digital sensors, but you developed the capability to make wafers so big that you can put 1 billion transistors on them, high quality, high reliability, low cost. And the industry has an infrastructure and an ecosystem that allows everybody to leverage these advances in technology. And I went back to Washington and said, look, guys, you need somebody to create the equivalent kind of infrastructure and build a community that has the equivalent of an Applied Materials that supplies all the people that want to make chips and companies that write software and write firmware. And basically I said to them, I don't do that stuff either, but in FIRST, I've collected 3,700 companies. Every one of the Fortune 500 giants that's in technology recognizes they want to be part of FIRST in their own self-interest. And I believe if I go out to the major tech companies of the world that have in-house the expertise, like the guys in aerospace that could design a better stent in 6 weeks. I said, if we go to the industries that know how to do things, high quality, precision, scale, do the documentation on it to meet really tough standards. And if those guys get around the table and we introduce them to the guys with the miracles in the roller bottles and Petri dishes, maybe we'll bring this stuff to scale. And it turned out by the time we sent in our final proposal, I had 82 of those companies and 26 medical schools all singing in harmony with each other. And now we're building this institution in New Hampshire. And I need a lot of you up there.
Well, and it's fascinating because until recently, the one place where computer vision has been deployed commercially at scale is manufacturing inspection. Right now, it's going into lots of other things, but we're kind of you're bringing us back to our roots and saying, well, we want to use computer vision in a different kind of manufacturing. Question here.
Dean, thank you very much for an inspirational talk. That was great. A lot of the folks in the audience work for companies that are technology suppliers, so they provide, processors, cameras, what have you. How, at a very practical level, how can they get involved? And first, how can they support your efforts?
Thank you for that question. In the first year we did it, as I told you, I had 20 some odd teams, and I went to companies I know. I'm in the medical business, and aerospace. I went to the companies and said, I need batteries, because I had to make kits. And even though it wasn't a lot of kits, if it had a couple of $1,000s worth of stuff, if I had to buy it retail, it would have been hard. So I went to these companies and said, put the stuff in the kit and I'm going to send it all out. And, GM gave us batteries and different companies gave us more. Well, over the years, we got bigger and bigger. And after about 10 years, one of the big companies, by then I had a staff of people that make the kits every year, said to me, Dean, we're getting pushback. I said, from who? I won't mention who, but a couple of big companies. And I called the CEO and I said, you were really happy to give us 50 sets of the part that you were making that year because you knew that the engineers at the other end would have to use that part to build a road. They'd have to learn your spec sheet. They'd have to use your stuff. If you were really happy to give us 50 sets of those parts 10 years ago, you should be 100 times happier to give me 5,000 of them right now. It's not like we gave them to one company and you're not going to get an order. I'm giving one to every potential client you have. It's cheaper than making a sales call. I didn't realize they're going to different companies, they didn't count us in, and we've never had another issue. Now, you look in those kits, if I had to start paying for software from every CAD company, there's probably $50,000 retail in those kits. And if I send out 10,000 kits, it's $50 million. But meanwhile, instead, we think it's not only not a cost to First, we think it's a value to all of our partners because you get to decide what you put in that kit. And if you don't want people running your code, using your sensor, don't give it to us. We think it's a really neat way to, if anything, help support our big suppliers. The simple question I'd give you is, or maybe answer your question is, if anybody here is at a company and you have parts or systems or software or anything that you want to be delivered to now a few thousand major companies that each one has adopted at least one high school. And by the way, if you do government work, the largest single supplier of teams last year was the Department of Defense with over 1,000 schools. NASA, 255 schools. And then, at 100 schools each, big guys, Boeing, Google, you can figure it out, IBM, GE. But if you guys have stuff that you want to be seen by these guys, give it to us for the kit. We supply one kit to every team. They have to use it to go build their robot. Trust me, they'll learn your stuff. And then you get to be mentors locally to help the kids around where you happen to be. And off we go. My vision is that First should be available in every school in the country. I was told that was too brutal by my board a while ago. I said, well, you used to roll your eyes when I said we're going to take over an arena bigger than the Super Bowl. This year we had to do Houston and 3 days later Detroit because we had so many people. We did 2 back-to-back championships because we had to take the winning teams. We had 1,400. Anyway, I've now calmed down. I'm the new kindler, gentler Dean. I don't say anymore we have to be in every school in the country. We just have to be in the schools where you give a damn about the kids.
Question over here.
Hello. Yeah. Hi, Dean. I'm actually a first alum. I want to say thank you.
Thank you.
And I also mentor my former team.
Thank you.
It's amazing. My question is about funding and getting companies to both have mentors and sponsor teams. I come from Miami, which is not a tech hub, so it's very hard to find sponsors or just help and mentorship. So how do you go about doing that both in the U.S. and globally?
So my favorite thing to do throughout the season, technically the season ended a couple of weeks ago, but it started with my first card, and on the back it said, "Come to Manchester." Now, as I told you, throughout March Madness, we've grown in our 28th year to have 160 cities hold regionals, about 20 cities per weekend. So nobody can say, well, it's hard for me to do. Kids have to get on airplanes and fly to your event. No, this is each line is a city during the 5 weekends, and this represents the 2018 season. And there is one in Miami. There's probably 3 regionals in Florida. You don't have to get pure tech companies anymore. The banks and insurance companies and all the companies that used to love to support other sports that, if anything, are a distraction from kids developing career skills, are now getting more and more sensitive to the idea that they want to be associated with FIRST. And universities. Every university is desperately looking to get particularly women and minorities, especially if it's a technical school, and they know that we are a very fertile ground. You go to a FIRST event, as you've seen them, and we got a lot of girls on these teams. We've got a lot of minorities because we adopt the right kinds of schools. So I think go to the local universities and community colleges, and they're very happy to give you the real estate to run the events, to give you faculty, to give you scholarships and support. We just got the governor of our state to announce that they will essentially give every school that has a teacher that signs up to be the coach the same stipend that they give the football or basketball coach. So that gave Little New Hampshire 144 new rookie teams this year. I think with a little bit of effort, let's face it, you're pretty successful, pretty technical people. You wouldn't be at this conference. You know people. It's easy to sit back and whine and complain about the school board or education. Engineers aren't about whining and complaining. They solve problems. Let the philosophers figure out, is that glass half empty? Is that glass half full? My question is there enough water in that glass to feed the world? And if not, let's make more. And by the way, let's make sure it's potable. But let's solve problems. Let's not talk about them. If everybody in this room decided you'd go back to your community and be just one school because it's your kids, or you went back to your company, and some of you have companies where you'd say, I want to run a regional. There's probably 50 of our 160 regionals that are sponsored by individual companies because they want to be associated with this. Go to our website and you'll see who they are. But between your leverage in your community, your leverage in your company, your leverage in there is no reason that the technical community of this country can't get enough support to put FIRST in every school. And it will have a larger impact on transforming the future of this country than any government policy you hear people whining about now.
Thank you. Dean, I can't think of a better note on which to end your inspirational presentation. Thank you so much for that absolutely fascinating and inspirational talk. Thanks for being here. And let's all go solve some problems. Thank you, Dean.